So now I will actually explain the Danavitt-Altenburg parameter when you can say describing the Danavitt-Altenburg representation. So for that, what I'm actually taking, you can say, I'm taking, this is the first body. So this is the first body. Okay. So this first body is actually rotatable with respect to this axis. So this is one of the, this is the first body and this is one joint. Now I'm taking this first body and the second body like this. Okay. So I'm taking, this is actually my first body, and now I'm connecting with the second body like this. Okay. So now this is the first body and this is the second body. You can see, right? So now I'm actually intentionally putting this way. So now you can see this is the case I'm trying to understand. Okay. So now this is one joint. This joint is actually rotating with respect to the, you can say, the first link. This is the second link. The first and second link is actually constrained with this rotary joint. So this is rotatable. You got it, right? So now I'm actually further I'm saying that this is having another joint which is actually connected here. So in the sense, so this link is having two joints. Okay. So now this is another joint. You see, this is the first joint of this link and this is another joint of the second link. So now this is the case I'm keeping. So the first joint is rotating like this. The second joint is rotating towards you. Okay. So now I'm taking the third body. So what that means? I'm taking a third body here. So the third body actually we'll see it is a translation or rotation. Right now I'm keeping as this. I'm not saying what you can say joint variable, but you can see that it is distance apart and it is actually rotation apart, right? So now the same thing I actually portray here. You can see this is the simple idea here. So I'm keeping, this is the first body. Okay, I'm just keeping, this is the first body. So what I'm showing here, this is the first body. And I'm keeping the second body like this and the third body coming towards you. So the same thing here I portrayed. So this is the first body I call link K or link I minus 2. Okay, so this is a link, the second link which is progressing. I'm taking a random link. So in the sense this is I minus 1 and this is link, you can say I, right? So now you can see that this is the way it is actually progressing. Now if you are seeing that the link I minus 1, if I take it randomly, so what you can see that is having one axis like this, another axis like this, right? So the same thing I am trying to portray outside just to understand. So I am saying that this is the first axis, which is actually I'm saying this is the midpoint as my frame. So I'm saying that this is the first axis. That first axis going towards the board, okay? And the rotation axis is actually like this positive. So I'm actually saying that, so this is what my first axis, okay? So in the sense, if I take, this is the link, virtual link, you can see that this is the second axis coming, right? So now this is your first axis, which is actually pointing or going inside. I'll just draw it with a white chalk because that is not at all differentiating whether it is white or you can say color chalk. White is good quality. So this is the first axis and you can see that the second axis having, you can say, vertical arrangement. I assume that the frame associated with link K or link I is here. This is link I minus 1 here. So now you can see that I want to know the information of, you can say, this with respect to this. So in the sense, so this is I'm calling I minus 1. Okay. So this link I minus 1, if you take, that would be having two axes. So link I minus 1 will have joint, you can say I minus 1 and joint I. So that is what we are trying to see. So this is another axis. Okay. So now you can see that if I see this body is having one frame here. This frame is common between, you can say, two body because this is the joint. I'm taking intentionally here as the ith frame. And intentionally I am taking I minus 1 frame here. So now you can see that the I minus 1 and ith frame are actually you can see very, very distant, or you can say distinct parameter. You can see that there is one displacement here, there is another displacement here, and there is one, you can say, rotation here. Further, further, you can see that how this link is arranged. So the link is arranging like this. So if I see, the link will go progressing in this way. So now, if I assume that the xi axis goes this way, I am assuming, because that is not given, I am assuming that the xi is actually like, this is a rotation joint, right? So in the sense, this link I can actually like rotate with respect to this any form. So in the sense, I can see that the xi goes like this. So now I'm actually like giving a label. This is associated with the joint. So obviously this is zi, and this is associated with another joint. So this is zi minus 1. And this is associated with a link. So it is called xi. So now I want to know the information of I with respect to I minus 1. So in the sense, what is my interest? I'm always going out, right? So I'm interested to get this. So the transformation matrix of I with respect to I minus 1. This is what my interest. So for that we will do set of transformations. Already we have seen that there are 4 parameters are involved in Dynavit. So in the sense, we are doing the 4 transformations. So whichever associated with the parameter, I am doing 1 transformation each. So that is what we are going to call as Dynavit-Hartenberg representation or notation. So then what first stuff or first thing we need to do? You see xi is given, but we don't know what is xi minus 1. So for finding xi minus 1, we have to take one thumb rule. You take zi minus 1 and zi and take perpendicular to this. So in the sense, I see where my zi and where my zi minus 1 is there. So you take, this is the plane, and you take perpendicular to the plane or normal to the plane. That is what your axis of xi minus 1. So in the sense, you can see that this is the plane where you can see the x, or you can say zi minus 1 and zi is located. So in the sense, you have to see that it is coming out of this plane. There are 2 ways. So one is actually going inside, the other one is going outside, right? But you can see that the link progressing in the sense, it is forward progressing in the right hand side. How I call progressing? Because your I minus 1 and I is actually like this side. So that case, I am fixing xi minus 1 here. So now this is one case, okay. Here it is very straightforward, easy to get, because zi minus 1 is going towards the board and zi is parallel to, or you can say vertical towards the board. So easy to get that the right hand or longitudinal direction is xi, I minus 1. But if this is not the case, what you have to do, you have to draw the common normal between these 2 axes, and that is the line of, you call x-axis, in the sense xi minus 1. So now this is the common normal which is actually like coming out of this, you can say 2 axes. So now this common normal we have drawn. Okay, so this is actually like 90 and this is also 90. You have drawn along the common normal, or on the common normal you fix your xi minus 1. Okay, now you fixed xi minus 1, then what can be done? So we have not done any transformation so far, right? So we are trying to do the first transformation. So for that we are taking the x as the, you can say, reference, because we are first talking about the link. In the sense, joint to joint information we are trying to pass. So for that I am taking the zi parallel line on the, you can say, frame of 8 minus 1. So this is parallel to zi. Okay. So now what I can see, this zi minus 1 and this parallel line is only, you can say, rotated apart. So what I can do, I can take xi minus 1 as the reference, in the sense about xi minus 1, I rotate this axis, I take this axis and rotate it to make it parallel. So what I am trying to do, I am rotating this. So now what I will get, I will get a new axis which I am going to call as zq. So since this is a new axis, I am keeping the xi minus 1 as the common. So now I am actually like saying that this is common to xq. Okay, so now what we got it, we got a new coordinate frame, that is I am calling as q. What we have done, we have done the rotation, okay, about, you call I minus 1, right? What we have done, we have rotated the frame, you can say I minus 1 in such a way that it maintained the q. So in the sense, this is the first operation we have done, but I don't want to write it this way. So we can actually like take it, okay, you can take it even this way. So this is the rotation matrix of Q with respect to I minus 1. You can write this is rotated about xi minus 1, and the angle right now we are calling twist angle. Why it is twisted? So you can see that this is what you consider as, you consider these two are actually like axis. Just to show you. So now you can see this is one and this is another one. Okay. So now you can see that these two axes are actually like twisted, right? So now if I actually like make it parallel, what I have to do? I have to untwist, then only I can make it in the sense. So these two PVC pipes, if you see, so these two are actually like parallel. Now what I'm seeing, these two are actually like twisted like this, right? One is actually like towards you and one is actually like vertically up. So now what angle you are doing? You are actually like rotating about this x and you are making it this. Right? So that is what you are calling twist angle. So now this angle called alpha, and since we are actually like rotated about xi minus 1, this is I call alpha I minus 1. So this is the first operation we have done. Okay. So then you can see that the Q we obtained, but I frame is still away, right? So can I actually like move forward? So what I can see, I have already have a common normal between these two. This is the shortest distance to reach. In the sense, so you have a highway and you are going on probably a service road and you want to reach, you assume that it is actually like a blank land. So you can see which is the shortest route so that you can go and reach the highway, right? The similar sense, you can see that already you have a common normal which is along x cube, and you are actually like if I travel across or along this, I will reach this point, right? So now this point I am reaching, so in the sense I am saying that the new frame we are calling P, this P have XP and as well as you can see ZP are parallel. Okay, ZP is parallel to ZQ and ZP is parallel to ZI also, right? Similarly, XP is parallel to XQ. So now what operation we have done? We have actually like distance traveled along the x-axis. So here we have taken XQ. So in the sense what we have done, we have translated. You can say what we have obtained. We obtained the P as the frame. So with respect to Q, we have translated along X. The distance we are going to call A. It is what we call link length, and it is with respect to original frame. This is with respect to I minus 1. That's why we call this is A I minus 1. Okay. So these two operations we have done with respect to what you call link. So now you can see that what we have done. So the joint to joint information we have already obtained. We got it, right? So now the question what you asked, it is coming now. So now we have already in the joint I. So the joint I is actually like what information it is giving? It is giving information between link I minus 1 and link I. So what are the information that is relative position and orientation? So that is what we are trying to do. I assume that already the xi is actually like going in this direction. You can see xi and xp. So these two are actually like rotated apart, and you can see the P frame and I frame, that is distance apart. But I cannot do as you can say single operation where both I can do. So then what I have to do? I have to do actually stage by stage. So in the sense, first what I am trying to do, it is something like you have a L bend. Okay. So you cannot go directly like this, right? You have to first rotate and then go. So that is what we are also trying to do. You are taking a parallel line parallel to xi, and I am drawing a line on the, you can say, or at the point P or frame P. So now this is parallel to xi, and now you can see that the xp and xi are actually like oriented apart. But which axis we can use for rotation? You can easily see, right? This is about the z axis. So now I am taking the z axis as the case like this right hand rule. The right hand rule says that this is the positive rotation, right? So now I rotated this with respect to theta degree, and this is rotated in general. It is rotated about, you can say zi, so it is called theta I. So now what we got it, we got a new x-axis, that is I am calling xr, and because of that I am actually like getting another frame, that is zr. So now you can see r frame has come. So the r frame is actually like how it is distance apart? No, it is actually like only oriented apart. So it is rotated about z. The angle is theta I, but what the frame is coming, that is the r frame. The r frame information I can see from P as like this, right? So now what else is remaining? The R and I is only distance apart, that too along Z. So I can actually like travel this. So this distance I call di. Okay. So now what I'm doing is actually like I'm translating z-axis, the distance d, okay, and we are doing along zi, so I am putting di. And what frame we are seeing? We are seeing the frame I, and with respect to what? R. So these are the four operations we have done. So now, in order to give little more clarity, I am just rewriting here. You can see this is what we have done. You can see q, which is actually like rotated about x, alpha I minus 1, and then you can see translated the p with respect to q along x, which is I call ai minus 1, then the rotation about z, so theta I, this is actually like the frame r with respect to p, then the translation of I with respect to r, the distance is actually like di. So if I see the earlier case, it is actually like with respect to moving frame. So obviously post to multiply. So that's why you can see I wrote it individual matrices. Now I'm actually putting in the sense. The first operation I rotated this. The second operation translation along x, then rotation about z and translation along z. So now since it is with respect to moving frame, because we are taking everything with respect to moving frame, so you can see that this is the post multiplication. So just EC2 you can see, so this is very simple as a simple transformation matrix. You can see these if you cut, so what you get, so the information of I with respect to I minus 1 frame. So that is what we have written, right? So this you will get, okay. So now in order to get this clarity, you can again come back here just for understanding. Okay, I hope you are able to see. If it is a physical class, you can easily see, but unfortunately there is no in-person class. So I'm trying to use whatever I have. So you can see that I hope this is the first link, and this is the second link, and this is the third link. Okay, so the first and second link is actually like rotated with respect to this. So in the sense this rotation is about this axis. So this is what you call I minus 1 axis. Okay. So now you take the second to third body. So that is actually like rotated like this, right? So you can see, I think you can see like this. So you can see this is rotated like this. So what that axis? This axis is like this. So this is Z type. Okay. So now what we have done first, we have not taken anything here. Okay. So what we have taken this random link. So this is the random link I have taken. So in the sense this is the one rotation. Okay. So with respect to this, we can actually like see that this can rotate, and with respect to this can rotate. So these information I have taken, and I put the third link in this way. The third link is coming towards you. So that is what here. So now with respect to, you can see that the xi is actually like going inside and zi is here, and this is what your zi minus 1. So what we have done, the first thing, so we have taken this link, and so this is what initially it was, and we are making it parallel. So this is what, first we draw the common normal and we make it parallel. So now you can see the zi and zi minus 1 are parallel. So this is the first operation we did. So where we obtained zq, right? Where the frame q. So that is what we have done. So this is with respect to x-axis, right? Because with respect to this axis we have done. So that is what the case. Second case, what happened? We are actually like take this frame and travel here. So in the sense, so now the link is actually like travel and reached here. So now you can see that this is what the case, right? So now this is the case, and your next joint, or sorry, next link is like this. Okay, but your x-axis is actually like coming towards, you can say, this door. Okay, so this is the axis, but your x-axis of the second or third link is actually like pointing you, but you have like this. So now what you can see, you can actually like make it that parallel. Okay, that is the third operation we have done here. So where xp is parallel to xr. So now you can see that this is your xr and this is your xi. So you can see that only the distance apart. So you come and reach. So in the sense, what you have done, first you rotated about x, you have made this, and you are actually traveling to reach the axis, you did. So after that, you can see that there are two implication. First, you rotate, in the sense when you are taking a right turn, you first turn and then do it. You cannot go drag and turn it right. So that is the case. So that is what we are doing it. So now you apply this individual matrix and you multiply, you will get it.